Now let's enter into postulate number 3. The postulate number 1, postulate number 2, and now to come with postulate number 3. According to Euclid, his contribution to postulate number 3 was more focused on a circle. As we have seen a circle with center and radius, so Euclid has investigated on the circle with its center and radius, and hence has come out with postulate number 3. Postulate number 3, as derived by Euclid, dedicated to the circles, the radius and center. So let's see what the postulate number 3 states. A circle can be drawn with any center and radius. This is what the postulate number 3 states. A circle can be drawn with any center and radius. So this investigation, clearly as evident on recognizing the different circles, was what has come out with the outcome of postulate number 3 by Euclid. As we can see, let's start with a circle. We know that when you take a fixed point and take a compass and just rotate it, I get a sort of a circle out here with the center here. Let me take the compass with a more bigger region and then I get the circle. Let me now take a very small region of the compass and then try to rotate. I get the circle. So here I have circle 1, circle 2, and circle 3, which have their respective radii. So each of the circles have their own radii in this case. So Euclid says that any circle can be drawn provided we have the fixed distance between what we derive the circle as. So according to Euclid, a circle can be drawn with any center and radius. This is with a center and a radius, and this is with another center and another radii, and this is with different center and radii. All three are circles. All these three are circles. So any circle, however big or however small, can be drawn with fixed center and radius, is what the postulate number 3 states according to Euclid's contribution to mathematical society. Next comes postulate number 4. Now Euclid is known also for recognizing or investigating many mathematical properties in right angle triangles. Just like Pythagoras has been investigating, Euclid has also contributed a lot on the right angles. The student of Thales, Euclid, has come out with his own contribution to the mathematical society. So let's see what the postulate number 4 contributes through the right angles. So the postulate number 4 says that all right angles are equal to one another. This might look very silly in the modern times, but it's very important that during those times where mathematics was very limited to its own knowledge was a very great invention, as with the postulate number 4 by Euclid. this is to be taken into mind very seriously. So postulate 4 says all right angles are equal to one another. Let's see how we can justify the statement. Let me take a right angle which is measured out here between the lines L2 and L1. Let me take another situation where I have a right angle, that is I have here between the sides BC and AC. Let me take one more situation where I have a right angle. For example, I have a circle or I have one more circle property which says angle in a semicircle is 90 degrees. So in this case, I have 4 cases of right angles, where in this case I have the line L1 which is exactly at 90 degrees. Usually 90 degrees is denoted by this symbol square. So this represents angle 90, is how I understand the 90 degrees concept. Similarly, I have triangle ABC in which angle C is 90 degrees through the sides BC and AC. Next, I have a circle in which at this point P, the tangent is set to make 90 degrees with the radius. This is the radius of the circle and this is the tangent, and at the point the tangent is set to make 90 degrees with the radius of the circle. Similarly, I take a circle which passes through the center of the circle, then this is called angle in a semicircle which is 90 degrees. So this is how I justify the property. In a semicircle, angle is 90 degrees. So in each case we have 90 degrees, which is different in different situations. But according to Euclid's postulate number 4, Euclid says all right angles are equal to one another. The 90 degrees here must be equal to the right angle which is 90 degrees here, must be equal to the right angle which is equal, or the 90 degrees in this case. All these 4 right angles are said to be equal in their own respective manner. So according to Euclid's postulate number 4, all right angles must be equal to the other, however different they are in their own geometrical situation. They are right angles, they must be equal. Now let's see the postulate number 5, the last postulate in Euclid's contribution. Postulate number 5. Now coming to the postulate number 5, before we discuss its complete definition, let me tell that all the 5 postulates are dedicated to Euclid, but the first 4 postulates are very simple to understand because they are self-evident. We can analyze, obviously, when I say all right angles are equal to one another, that means 90 degrees, it will be same anyway. So they are not that much focused on, but the 5th postulate, which is very complex, is how Euclid has contributed to developing the geometry as ages pass by. So let's see the postulate number 5 contributed to geometry. According to Euclid, if there are 2 lines out here, and then if there's another line which cuts this with interior angles being, say, this is x and this is y, then if x plus y is less than 180 degrees, according to Euclid, this was referred as 2 right angles. So according to Euclid, if sum of these two angles formed by the line, so this is P and Q, if this is the line PQ which makes the angles X and Y in the interior angles on same side, say for example, if I take on the left side of the line PQ, the interior angles are X and Y and the exterior angles are the one which are outside. So when I take the interior angles X and Y, the condition is if X plus Y is less than 180, then the postulate number 5 says the line PQ cuts the other two lines L1 and L2, and obviously in this case here they cut at P and Q, is how I understand the postulate number 5 as connected with intersecting lines. So with the condition that the two interior angles on the same side of the line being less than two right angles, that is one right angle is 90, so two right angles make 180 degrees. So we call 180 degrees as two right angles. Then if the sum of interior angles is less than 180 degrees, then the line PQ, as clearly can be seen here, cuts the other two lines L1 and L2 obviously at P and at Q, is how we understand the postulate number 5 as contributed in the mathematical society by the great mathematician Euclid. Today's session is about postulates. The Euclid's postulates is what we are going to define or discuss more of in today's session. So let's see what are postulates. So the contribution of Euclid's postulates, but before that we will try to see what exactly the word postulate means in mathematical understanding. Before we discuss in brief about Euclid's postulates, the 5 postulates as contributed by Euclid in the mathematical society, let's define what a postulate is. What is a postulate? The term, which looks very complex in mathematics, has got a very wide definition and which plays a very important role in the benchmark of geometry. Postulate means making a statement on observed phenomenon. Postulate generally means making a statement on observed phenomenon. Its proof, its truth and validity is then checked later on. So here I have these two important things which are interlinked and defines a postulate. It's very important to understand a postulate in mathematics before we get into understanding geometry. So in mathematics, it is assumed that there are many proofs or theorems or many axioms or many postulates which have been invented or discovered by the past mathematicians. So here the postulate is defined to be making a statement on observed phenomenon. So generally when I make a postulate, it is about that I don't prove it, but I just make a statement on observed phenomenon. Just like I point out in the student, if a student is consistently talking in the class, then I rate him as a talkative person. This is the statement which I make on the observed phenomenon during the class session. In the similar manner, when I observe certain mathematical properties, it to be true in all times, then I say this will be true forever, and hence it's a postulate. To continue with this, its truth and validity also plays a vital role. When I say that I make a statement, I'm not going to make it unjustified. When I say the student is talkative, I'm not just cursing on him, or I'm just not taking revenge on the student. It is because his behavior in the class is talkative, I point out saying, you are talkative. So similarly, when I justify on whether the statement which I'm making is correct or wrong, I try to justify it on later on by applying that into the situation. Let's take an example problem to understand the postulate more better. Imagine I have 2 points which are distinct and very far away. Now I take a ruler and I try to draw a line passing through them. So when I take the ruler and just try to draw a line, I just see that there's only one line which can be drawn. So for these 2 distinct points as taken on the plane, let's see how we can connect this with a postulate. Imagine the 2 distinct points A and point B. Now let me just investigate on a property which can be invented or derived from this investigation of 2 distinct points A and B. Now for these 2 distinct points, I would like to see how many number of lines I can draw. So I try to make an attempt in drawing this line which doesn't pass through the points. Then I make an attempt to draw a line passing through this and attempting to make this line pass through the other one. This also does not pass through the other line. So with this investigations, I wonder to see, is there any line which can pass through the 2 points, and how many such lines can be passed through that 2 points. So as I see here, I come across a line which is set to pass through A and B. Now out of the different lines I have taken, I recognize that there is only one line which can pass through these 2 points. Or out of all the different possibilities of different lines I take, I see that there's only one line which passes through A and B. So I make a statement through my observed phenomenon which says that there's only one line which can be made to pass through two distinct points. Then that makes my statement, which is on the observed phenomenon. Now comes its truth and validity, which is checked later on. So I take the plane, I plot the points, the 2 distinct points, and then try to make different lines possible. Then I check through the validity that yes, there's only one line which can pass through the 2 points, and hence it is called a postulate. Similarly, I take a point and I want to see how many lines are possible to be drawn from this point. So I investigate with 1, 2, 3, 4, 5, 6, etc. So different lines pass through the point. So I make the statement that there are infinitely many lines which pass through that point. So my postulate is about making a statement on observed phenomenon is that infinitely many lines pass through the point on observed phenomenon. And I check through the truth and validity. I draw the different lines and I see that there are infinitely many lines which pass through the point. Is how the postulate comes. Truth and validity check out. And only if it is true, we call this as a postulate. If my truth and validity, which is checked later on, does not prove the made statement, then it cannot be a postulate. We cannot call that a postulate. Postulate is a statement made on observed phenomenon. Its truth and validity checked later on. If the truth comes out to be universally true, then the statement is a postulate. It must be called a postulate. Euclid's postulates to be followed with.
If you like this video, please give a thumbs up. Please subscribe to our channel to get more videos on CBSE syllabus.